Alright, welcome back to another episode with the kid screaming at linear algebra or something similar. Well, into this semester, I've learned about vector triple product expansion using cross product for three vectors, and it's basically used for computation to make it easier. A normal vector from plane equation, which is perpendicular to the plane, and the distance between planes, with how you do that is you use the normal vector because they're parallel to each other, and then you measure the distance between them using other techniques. Matrices for solving systems of elimination, well, you use row echelon form to solve systems of equations making planes. Alright, the reduced row echelon form is basically how you take a matrix of numbers and then you try to cancel them each other out until you have the pivot variables, which is 1, which is in the column, the only one there is. And the only number 1 there is. And the other ones are free variables, which you can change to anything. And we also learn how to use matrix row echelon form in order to show a linear system has no solutions. Basically checking using the method of reduced row echelon form. Matrix vector products talks about transpose, which is a T on the subscript, which basically flips a column into a row. And introduction to the null space of a matrix. What makes a null space and what properties does it need? Like null space is basically kind of like 0, where anything you add has to be in that null space. Everything you multiply has to equal something in that null space. Alright, calculating the null space of a matrix equals to the reduced echelon form of the matrix. Now, if you calculate the null space of a matrix, the best null space of a matrix, sometimes, I don't know about other things, but right now, it's basically 0, because anything you add to, like, anything that's inside that adds to 0, or multiplies 0. So 0 plus 0 equals 0, 0 times 0 equals 0, 0 times anything equals 0. I don't think about the addition, actually, but the multiplication, yes, is anything times 0 would equal 0. So anything times anything would equal a number in that subspace, the null space. Alright, so relation to linear independence. Alright, no, wait. It's calculating null space of a matrix. Null space equals to the reduced row echelon form of the matrix. If the null space of a matrix only contains a 0 vector, well, that means the columns are linear independent. In the column space of a matrix is the span, basically. Null space and column space basis for the so they can make a basis for the column space, which is the span, making it linear independent. Visualizing a column space as a plane in R3, it can replace anything in the plane because it spans it. There's a proof of any subspace basis has the same number of elements, which is basically how the basis or the span elements will always be the same from the number of that span basically the linear independent elements. Dimension of the null space or nullity. The dimension of the null space equals the basis for the subspace, which are the number of non-pivoted columns. Dimension of the column space or rank. Dimension of the column space is equal to the number of bases for column space, same for rank. Showing relation between bases, calls, and protocols shows that the null space of the reduced echelon form is the null space of the matrix, showing that the candidate basis does spawn column A, because free variables can be set to anything, and they can get it by itself, to equal the private variables. Since they span it, it works out. For a more formal understanding of functions, instead of thinking about it as replacing something like f of x, and then you replace whatever is in f of x with that x, like f of x equals x squared. If you put it in 2, then it would be 2 squared, which is equal to 4. Now, basically, the f of x would be equal to uh, the the codomain, which is equivalent to the x squared on the other domain, which would be 4. So the codomain 2 would equal to domain 4, which is where you get the f of x, which is a more formal understanding of the function.